For question 1, part A, we will be computing the integral of sine 7x cosine 4x dx. For this problem, we need to use a trig identity. We will use sine A cosine B equals 1/2 times sine of A minus B plus sine of A plus B. We have our integral of sine 7x cosine 4x dx. From here we can identify that 7x is our A and 4x is our B. We can plug this in and get the integral of 1/2 times sine of 7x minus 4x plus sine of 7x plus 4x dx. Simplifying this, we get 1/2 sine of 3x plus sine of 11x dx. We know that the integral of sine ax, a being a constant, gives us negative cosine ax over a. Using this, we can get 1/2 times negative cosine 3x over 3 minus cosine 11x over 11. Distributing the 1/2, we get negative cosine 3x over 6 minus cosine 11x over 22, plus our constant of integration, c. And that is our final answer. For question 1, part B, we have a spring has a natural length of 28 centimeters. If a 28 Newton force is required to keep it stretched to a length of 36 centimeters, how much work W is required to stretch it from 28 centimeters to 32 centimeters? Round your answer to 2 decimal places. Now, the two formulas we need for this question are for force and work. For force, F equals K, the spring constant, times X. For work, the formula is W equals the integral from A to B of Kx dx. Now, our first change in X is 8 centimeters, which is equal to 0.08 meters. We're given the force, 28 newtons, so we can set it equal to K 0.08 meters. From here, we can divide both sides by 0.08 meters, and we're left with K equals 28 newtons over 0.08 meters, which is equal to 350 newtons over meters. Now for the second change in X, we have 4 centimeters, from 28 centimeters to 32 centimeters, which is also equal to 0.04 meters. Our A is going to be 0, and our B is going to be 0.04. We know that K is equal to 350. We can start off by bringing the constant K in front of the integral and finding the antiderivative of x, which is x squared over 2 from 0 to 0.04. Now we can plug in our numbers. We have W is equal to 350 times 0.04 squared over 2 minus 0, which is what we get when we plug in 0 for x. This is equivalent to 350 times 0.0016 over 2, which then gives us work is equal to 0.28 joules. And that is our final answer.